All right, so alternatively to building a table, plotting a bunch of data, finding R's, and so on, a better way, or maybe just a different way, to plot polar curves is just graphing whatever this function is and interpreting what this graph means in terms of the polar grid. So if you don't remember how to graph these, I'm not going to be teaching you how to do that. Now I have a different video that teaches how to do that, but I will be just graphing it directly, and I'll be linking the video underneath so you can down below so you can follow to that video that explains how to graph. Okay, so generally speaking though, whenever you have a function that says y equals a cosine bx plus c with a plus d outside, you should know that this is just a shift that shifts your function up and down. The period of your function will be 2 pi divided by b, because that's telling you how fast x is changing and moving on. C is going to tell you about the phase shift, so that will be how later or earlier than 0 your function will begin, so that phase shift. So the new 0 basically is going to be whatever value you get by making bx plus c equals 0. So x is going to be negative c over b like this. So if you have a positive c, then your function shifts to the left. If you have a negative, depending on b, of course, as well. And a is the amplitude, meaning this is a vertical stretch on your function. So with all of this, I'm not going to be keeping track of this for this example, but with all of this, how can I graph this particular function? So this function has no phase shift, so it will start at 0. The only change to this function is that it has a period of 2 pi over 2, which means pi. So how do I graph this? I generally go, and I have grid paper, so that helps me a lot. And I'll put the period here. And I will always divide my period into 4 parts. So for me, this will be half of pi over 2. Half of pi over 2 again is pi over 4. And this will be 3 pi over 4, so halfway between pi over 2 and pi. And then 4 more units completes the 2 pi for me. I always need to go, even though the period is only pi, I always need to go all the way to 2 pi, because on the polar grid, I need to cover the entire 2 pi angle that I could look at, right? Whenever you're giving instructions to find a point, you need 2 pi, you need 270, you need 150, you need everything. So even though you only go to pi, doesn't matter what your period is, you want to cover as many as possible. So, but I'm going to graph this period first, then I'm going to repeat whatever happens on the other one. So I know that the regular cosine function starts at 1. 0 is 1, right? Cosine of 0 is 1. So I'm going to be 1 here. And then the cosine, this is 1. Plot 1 there. And then the cosine function goes down to 0. Then down, then up, then up. So you gotta know how to graph these. If you don't, you gotta review before you go about plotting curves using these graphs. And so because cosine is periodic, and I've already found the period, what happened here is gonna happen again. So it's gonna go down, down, up, up. So it's gonna be like this. This is gonna be the graph of, this is not the graph of my polar curve. This is y equals cosine 2x. Right, this is y and x. Now, how can I possibly use this to plot my polar curve? I'll tell you, I start with the zeros, right? Whenever I'm at pi over 4, 3 pi over 2, and these are, I've got to go a quarter of pi each. So this is 5 pi over 4, and this is 3 pi over 2, right? Which would be 6 pi over 4. and this would be 7 pi over 4. So almost 8 pi over 4, which would be 2 pi. I see that I'm dividing pi into quarters, so I'm going to go and sort of dash these lines here. This is pi over 4. And I'm just going to count everything. 1, 2, 3, 4, 5, 6. So 3 make a half. So this is the other. Dash this. Dash this one. This one, and of course this one as well, and this one as well. I already knew about these. All right. And so I'm thinking about this. What's happening between 0 and pi over 4? One piece at a time. What's happening on this piece? So at 0, I'm pointing towards 1. I'm going to make it a little bigger. Instead of using each unit here as 1, I'm going to make it a little bigger. I'm going to say this here is 1, just for the sake of having a slightly bigger scale. Maybe I can even make the whole thing be 1 here. Let's say 1 is here. And for pi over 4, I will be at 0, but for the angles in between, right, I'll have r values that will be slightly decreasing. So as I trace those rays here, I'll go a little shorter, a little shorter, a little shorter, a little shorter. So my curve will trace something like this before that dashed line that I drew initially. So just imagine, right? If I look at this angle, I'll be a little less than 1 away, a little less than 1 away, a little less than 1 away until I reach 0. So I'll end up with something that looks like this. Now on this piece, after pi over 4, I will be having negative y's, which means I'll have negative r's. And so up until pi over 2, okay, pi over 2 will be negative 1, so it will be right here. Pi over 2, I face this way, but because r is negative, I go downwards. So in this sector, I'll be moving back, but then further and further. So I move a little bit back, and then a little bit more back, and then a little bit more, and then a little bit more. So I'll be tracing something like this as I rotate around. So this is more or less what I'll get. And now again, I'm increasing. So I'm here. I've already covered this portion. Now I'm going to cover this portion from pi over 2 to 3 pi over 2. I'm going to change from -1 to 0 again. So I was very far. It's going to be less negative, and then less negative, and then less negative, and then less negative. So my curve will trace something like this. Okay. And then after that, it's going to grow back to 1 until we get to pi. So something like this. And then after that, it will decrease from 1 to 0 again. And then after that, it will go from 1 to -1. So you are between 5 pi over 4 and, and 3 pi over 2, that's correct. So you would be right here, but because r's will be negative in this piece, you would be pointing to the opposite side. So you will be right here. So you'll be going all the way to -1 when you get to, you see, 3 pi over 2, -1. 3 pi over 2 would make you face this way, but because it's negative, you'd go all the way back to the other direction. And if you continue this idea, you can see, I'm going to close this up this way, and then you're going to close this up this way. So this is going to be this four-leaved rose curve. This is called a rose curve. 4 leaves. So pause as many times as you need, trying to understand what these calculations are saying and how I'm making the decisions to plot these points. If you're not exactly sure, try and choose some values in between with your table. Just do a few values in between 0 and pi over 4, maybe with the table. Make a decision that this is what's happening, and then go back and understand what I'm doing, right? Without actually plotting the values and just following the graph, okay? Here's one more example that I'll do with this. I'll go over this one. It's a little bit different because you have the plus in here, but right now you have a period of 2 pi over 3. And then you have a shift upward of 2 units. So your graph is no longer going to be between -1 and 1, right? So sine 3x is between generally -1 and 1. But this time, as I add 2 to all sides of this, if you have a hard time understanding this, you can think about the inequality one pair at a time. If you only have this, you add 2 to both sides, you would get that 2 plus sine 3x is going to be between 3. So just add 2 on these two sides to get this, and then add 2 on these two sides, right, to get that you're between 1 and 3. And I'm not wrong, I didn't make a mistake. This is actually x, because I'll begin not by plotting graphs in terms of theta, but I'll graph in terms of x. Y equals that thing first. So I'll be graphing y equals 2 plus sine 3x first. So again, I'll be between 1 and 3. 1 is going to be 2, 3 right here. And I want to always cover space between. I want to make this move a little bit to the left here. I want to always cover 2 pi. With your angles, but respecting the period of the function. So we just found that the period was 2 pi over 3. So I'm going to plot this right there. I always divide my period into 4 parts. So this is going to be 2 pi over 3 right here. And then as I divide this into 4, right, I'm going to get right here a 2 pi over 12, 2 pi over 12, which is the same as pi over 6. It's very convenient. This will be double that, right? Pi over 3. And then this would be pi over 3 plus pi over 6, which will be 2 pi over 6 plus pi over 6, which is 3 pi over 6, which is pi over 2 right here. Okay, it's important to simplify those angles so that you know where to place them in the grid, in the polar grid. Okay, it's really important. And the sine function, instead, opposite to the cosine function, it starts at 0. So when you start plug in 0 here, you get 0 for the sine, but then plus 2. You start at 0, sort of at the middle, in the middle here. So you'll have 0, and the sine function will go up, down, down, up. So it will do this. If you know how to graph these. If you can graph these quickly, that's good for you. I'm going slow because I want to be able to show everybody how to do it. And then, of course, what's going to happen, right? I want to go all the way to 2 pi, and 2 pi over 3 is obviously a third of 2 pi. So that means I'm going to go 1, 2, 3, 4 one more time here to get 4 pi over 3. And then 1, 2, 3, 4, a little more to get 6 pi over 3, which is the same as 2 pi. So that is all I need. I want 2 pi again because the polar grid dictates. So this is going to be repeating because the function is periodic. That's what period means. We're repeating the same behavior over and over. So we're using this. So what is happening, right? What is in fact happening to this? Let's look at one piece of this at a time. From 0 to pi over 3, we have a distance of 1 that increases to 3. So right here I'm going to start with this at 1, and that distance increases all the way to 3 at pi over 6. So again, I'm going to measure my pi over 6, and this is going to be 3 right here. Okay. Each of those on my grid is pi over 12. So to get pi over 6, I need 2 of these. So my curve is doing this. So we're connecting these dots as we increase to 3. And you can see this sort of a looping behavior there. And then after that, the distance decreases back to 1 until it gets to pi over 2. So we're going to go at pi over, let me double check if I'm doing this right. At pi over 3, we should be back at 2. Yes, I was doing this wrong, right? Because this is 2. This is 2. So we don't start at 1, we start at 2. Good thing I checked. And then on the next step from this piece here, we decrease from 3 to 1. So pi over 3. So this is 0. This is pi over 6. And then pi over 3 will be obviously double this. So it'll be pi over 3. So we go back to 2 in this one. 2 units away from the origin. And then at pi over 2, now we're at 1. Yeah, that's what I was getting confused with. So we're doing something like this. And then have, and we can see now, right? Each 2 of these corresponds to 1 of these. Just take a look. Each of those little divisions at the y equals 2 plus sine 3x is pi over 6, and so are 2 of these sectors here on the polar grid. So I can just follow 2 more units on 2 more angles on the polar grid, decreases from 2 to 1 like this. As I got to pi over 2, I've already covered this, so I can move 2 more units, go back to 2, 2 more units, go back to 3, 2 more units, go back to 1, 2 more units. I'm doing this right. Go back to 2, I should have said. 2 more units, go back to 1. So we're going to do something like this. And then 2 more units, go back to 2. 2 more units, 2 more angles, I should say, right? 2 more sectors. Go to 3. 2 more, go back to 2. 2 more, go to 1. So we're going to draw something that looks a little bit like this as we trace it around. And again, you can use your, whatever you use, Desmos graphing calculator to double check this work. I hope this makes a little bit of sense. It's complicated, so maybe you got to watch this multiple times. And you can always ask me questions if you need to.